Okay, so
Tan.
oh, this is your screen. Okay, perfect.
Yeah, this is my screen, so I want to close it. Everything. Okay. So now it is the beginning.
Yeah, so you have which project are you currently? Okay, local WS. Okay, that's the one. Oh, you have Visual Studio 2019.
It's 2019.
Yeah.
Where do you see 2019?
Local
You see it in Solution Explorer.
Visual Studio 2019.
Can you go to help and see what?
Yeah, that is what I'm. How to remove this window? Stop sharing this. I always get this window.
Oh, you can click on the I think there's a way to hide it. If you click
Yeah,
on
you can click pin, then unpin, it will go.
Yeah.
Ping and unping, okay.
In the last there will be a pin sign, so you can click on that and then click again, it will go.
No. Where is it's a help?
Yeah.
About.
No, that's okay. You have 2022.
2022. Yeah.
Yeah, Microsoft Visual Studio Professional 2022. Okay. Yeah.
Perfect. And you have the license, right? Can you go back to that screen? Sorry, Pravesh. Go back to the About screen and click on My License Status at the top right.
Oh, sorry.
No, that's fine. That's fine. License. You see license status in the box? In blue.
In the box.
Go up.
Above.
License status.
There,
okay.
License status.
Yeah.
Okay, product key applied. Okay, you're good. Okay, I just wanted to make sure that your license was applied properly.
Okay, so it's a license product key applied. So it means I'm good.
Yeah, they did it remotely. So they applied the key to your install. Okay, you can close. So basically, what we're going to so you see the Solution Explorer is where you're going to have all your files, your project files. So if you expand the local WS node.
Here, look this one.
Yeah, expand it. Okay, and you have your source files and you have your header files.
Source files, okay.
And this is where you have all your C files, and unfortunately, this project is going to be mostly C based because it was too difficult to convert this into C++. So I left it as C. But I have another project that's a DLL that's also used by CPTS EMUTS, but only to generate the DDF report. And that one is C++ based. So if we go through this one, the first thing I want to show you is if you right click on that top node, local WS, and view
Tan, before we start, actually, now how this is coming, it's coming automatically.
Oh, how did you open it? How did you open it? Yeah, very good question. How did you open this project?
Actually, yesterday I copied all the source code from GitHub.
Okay.
Here in my local, it's my local one, right?
Right.
So what I did here, I think it's files and open, and then I think I tried to clone the repository. I don't know.
Yeah, what you could do that, or what I do. Let me share my screen. I'll go over it quickly, and then what I do is basically, let's say you can see my screen.
Yes.
Okay, so let's say if I start another command line, let's say I'm gonna go into, oops. Okay, I'll put it in here. So if I go to GitHub, and I have, it's under PLM. So you see, this is the one that we want.
Yeah.
This one is C#. So this one is the user interface, but you won't be modifying this one. You will be modifying this one. So if you go here, you click here, you click on code, and you copy the directory here. I did a copy, and then what I do is that I do a git clone here at the base directory where I want the CPTS EMUTS DLL code to be. And then I do a paste of what I just copied in here. And then I just run the clone, and it's going to reproduce exactly the same tree in GitHub in here. So all I have to do is I have to go to CPTS EMUTS DLL, and this one shows the branch where I'm on. Origin means remote. So you see, this is the branch here. The branch is master. So I currently have the master branch on my local. So I have all the code here. I think the way the project was set up, it's like it doesn't have a source file. So I think I set it up so that the project is basically here, you know. So basically the project is in this subdirectory, but anyway, it's the way the code was done in the past. So what I'm going to do is that I'm going to go to that project directory, and then you have two files. You have the SLN, which is the solution project file, and then you have the VCX project. So you can open either one of them. So what I'm going to do is that I'm going to open the local WS SLN, because that's the one that you want to open usually, and this one will open your project file. So usually when you open it, I don't know if you have this, but it's going to ask you which Windows SDK you want to target. And you remember this was where I was asking you guys to download this one here, because this is the latest one. And the version 1.4.3 is basically, it's equivalent to Visual Studio 22. So 2022 is version 1.4.3, and version 1.4.2 is 2019. So we're gonna use version 1.4.3, and that's how basically you get to this screen here. So you get to the screen. I'm gonna wait for it to. So you could probably do the same, Mansi, if you want.
Yeah.
Just do a git clone of that into a repo, and then Pravesh, it's up to you. You can reuse your existing folder, or you can create another one. The advantage with using this is that let's say if you do a git status, for example, you see it tells me that everything is good. I don't need to there's no changes in my local branch that I need to update in Git. But let's say I'm going to wait for it to finish. I don't know why it takes so long. So here, there's a bunch of other things you can do with Git, but if you, this is the command line version. So, you don't need to worry about that at the moment. When you're ready to update the GitHub repo, I can walk you through the things that you have to do. one of the first things you do is you do a git add, and then you add all the changes to your local branch, and then you do a commit, and then after that you do a push. And when you do a push, basically it pushes to the remote Git repo here. I'm not sure why my thing, I think it's crashed. So it's weird. Okay, I'm gonna open an existing one. I'm gonna close this one. Oh, it's probably because I already have, I already opened it.
Mm-hmm. So Mansi, just wait, and when you will share your screen, so you can set the repository. I think yesterday, I tried to clone the repository, so that's why you can see in my case this folder.
Yeah. Okay. Okay. Perfect. So let's try again. Okay, it looks better now. It's probably because I had so if you can follow, like Mansi, let me know when you get to the point where you can open the project. So
Okay.
but in the meantime, I'll just move forward. So Pravesh, one of the first things you once you get used to the user interface, the first thing you should do is do a right click on local WS and open it. And this is where your project properties are. Most of these you don't need to change. So the configuration type is for a DLL. You could do an EXE if you want. In our case, we'll be using the dynamic link library. This is the Windows SDK version. And as you can see, we have version 1.43 targeting Windows Visual Studio 2023. This one doesn't really matter because we're working with C. So that's it for general. Advanced, we don't need to do anything here because everything is mostly done already. What we're gonna go to VC++ directory. So in this VC++ directory, you got to make sure that you have these directories on your pad. Yeah, I forgot to mention you need to install the instant client 12-0. Let me see. I have it on my machine, so maybe I can share it with you. If you don't have it, okay. Oh, I have it already. Okay, let me put it here. This is for Oracle 19 and 21, so we'll be using the Oracle 12. It's taking forever. Okay. Anyway, while it's copying, so this is you need to make sure you configure the executable directory, the include directories, and the library directories for it to compile properly. So
yeah, it's very important. I will looking for that.
Yeah, and you also you can update the reference directory as well. So if you go in, you click on the, if you go in here, you can do it manually from here instead of doing you can do it one entry at a time as opposed to doing it like I prefer the other approach, but you can do this one too. Once you have your directory, you just click on the three little dots and you go to the directory where you have your instant client. And you have to make sure that you have the base one and also the SDK lib MVC, yeah, MSVC, because this one is another compiler. This one is the Microsoft compiler, and you also need the OCI library, which is this one here. So that's for executable. It's the same thing for a library. Execute library is the same thing because we use this for the DLL. This is for the EXE. The include directory, we need that for the header files.
So all the header files, I think for every the .c file, we have a header file, right?
Yeah, exactly. But these are not those. These are header files from the instant client and header files from OCI lib. Yeah, OCI lib we use as well. So let me see. You see these these are the header files that we use in the project.
Okay.
But the header files that I'm showing you here are the header files for dependencies for references.
Okay, got it.
Yeah. So I think they're yeah, they're probably shown here or here, but these are the local ones. These are the local header files. So yeah, so these are the source files. They're under source files, and these are header files. So once you have that set up, this is really important. Once you have this set up, make sure also that you have this one, Windows SDK include path, and because this is important because this will tell you where to get the Windows header files. And in my case, see, I have them pointed to C programs Windows Kit and the version that I was asking you to download. So once you download that, it should be in this directory. So by default, when you download it, it's in C program files 86, and then that's the default installation. Always goes there. So you have Windows Kit here, and then you have 10, and this is where you're gonna go into bin 1026. That's for the executable. For lib 1026, include 10.0.226, whatever. Oh, okay. The instant client is available, so you can download it from here. Sorry. Maybe I should zip it because it's going to take a while. Put it in the chat. Yeah, just make sure you download the 12-1. This one here, 12_1, not the other ones. Okay. Now, other than that, let's go back to the project. So once everything is done, what you do is that you do a build and then rebuild solution. Then you should have an output window. Yeah, so you can see that this is the one that I downloaded from. I did a clone, but the path hasn't changed because I changed computers. So these paths are not the same anymore. So what I'm going to do, I'm going to reload my the project that I modified, so that I will have the basic ones basically. So basically, JPads. There you go. So this is the one that I changed. So basically, if I go in the project properties, no, that's not the one. Sorry. Local D development. Okay, it's supposed to be this one. D development repo. So this one, 2015. Which one did I change? Is it this one? No, it's not this one. Sorry, I'm looking for the ones that I modified. I don't want to do it again. Oh man, I don't want to do it again. Okay, my recent projects. C development code JPads. Oh, okay, this one. I think it's maybe this one. Code JPads. There you go. This is the one. Yeah, this is the one because I have D on my D drive. So basically, once you configure yours, it's going to look. You have the proper path to the executable, the include, the library. Then you do a rebuild. Rebuild solution. You go to output. There's a lot of warning, but the warning is because the code is very old. But it should still work. It's because of they used to work with double and a lot of type conversion. But anyway, so the output is created. So the build is done. You see the result, the message here: 1 succeeded, 0 failed. So as long as you have 0 failed, you're good. So
okay. So Than, here when we are saying rebuild means it is compiling the code, right? If we change anything in the code, then we will rebuild it. That is what we are doing, or?
Yeah, it's compiling and generating the DLL.
Okay, so generating the DLL, and we have for JPET, when we start the JPET application, we have .exe file there where we click it. So it is reflecting there, right?
The exe,
Do you follow
not
me?
the exe, the DLL, not the exe.
Oh, okay, not yet. It's for okay. That is the
Yeah,
local dependencies. Okay.
Yeah, you see, if I go here, this is where my project is: development code JPAD CPTS EMUTS DLL, and then local WS, and then you see there's a debug folder that was generated today.
Okay.
So if you go into the debug folder, you see the DLL that generates. It's this one. It's just generating it at 10.
Oh, it's generating the DLL. Okay.
Yeah. And so this is the DLL that we'll be using for if you recall you go back to that diagram. If you recall this diagram, so this is the DLL that we just generated here. This DLL will be used by the C# user interface code. So this is the one. So we generated from running the build on this. So if you wanna clean it, you can do it. If you do clean, then you should, if you go here, you see in debug, everything was clean except maybe, so I can clean all of this. I can go back and I can clean this. Don't clean the packages because the packages will include all your dependencies. In this case, there's the OCI lib here. So let's go back here. We go here and then let's run the build again. We don't have to do a rebuild. In this case, we just did a clean, so we can do a build solution. This is incremental. So when you do a build, it does an incremental compilation. So it only compiles your changes. You see, so now it just generated the DLL again. You see that message here, and you go into debug, and you see the DLL was generated at 10:31. And these are all the OB. This is the compilation object files, right, from the C. So when you compile C, it generates OBJ files, and then after that, there's a linking process in C. This is where you might see. So when you compile C and C++ code, there's two steps. There's the compilation, and then there's the linking. So basically, the linking, what it does is that it takes all your OBJ and then it converts it into a DLL, and it converts it into native code so that Windows can run it. The linking is very specific to the operating system. So linking on Unix will generate like a Unix executable, and linking on Windows will generate either a DLL or an executable. Yeah. So if, let's say, regarding GitHub, let's say if I go here and I modify, I don't know, The interface is always, you see CPTS, EMUTS, DLL, that's the interface. So the interface, basically the entry point to the DLL, this thing here.
Mansi, can you include Camby in the call?
Okay, sure.
Oh, Camby is there?
Yeah, he wants to be in.
Okay.
Yeah. So can you please repeat what is it? DLL? You were there. DLL.
Yeah, this file here is the entry point of the DLL. So it defines all your basic entry points for the DLL. So the entry points could be read DDF archive, write DDF, scan DDF, extract DDF, CPTS, EMUTS. The ones we use most often from the code is from the C# code is read DDF. We also use scan DDF, CPTS calculation API, and EMUTS calculation API. So those are the four main ones that we use.
Okay, so Than, these four. So when we open the application, then at the right hand side we have those options. So these are linked with those options, right? That's what you're saying.
Yeah, exactly. So those four entry points you see are what's here. Yeah, so these entry points are used by external apps, like in this case CPTS, the C# app. That's where it's being used. So the read DDF is being used by the flight data management or DDF management module in C#. So basically, it will call the read DDF and scan DDF. So that's this line here. CPTS calculation module in the C# will call the CPTS calculation API entry point, which is here. And EMUTS calculation, we'll call the EMUTS calculation API. And these API, what they do is that they will do calculations based on the DDF that we receive from Textron, and then they will store these calculations in Oracle views, CPTS views, and EMUTS views. I'm talking mostly about the CPTS calculation, EMUTS calculation, these two lines. This one will read the DDF from file, and then it will store it into a blob that maybe I can show you in the database.
So Than, we will compile the code through Visual Studio. There is no need to compile through Makefile. We don't have any Makefile, right? Sometimes we also compile code from the prompt.
Yeah, everything will be done directly from Visual Studio.
Got it.
Sorry, I don't have JPads here. I had problems connecting with JPads last time. So yeah, so basically everything you do is you do directly from this editor. So like I said, you do just build a solution, and then once your build is working fine with, you make sure you get this worked out, the directories. Usually it's a problem with the directories. Make sure that you also have your Windows SDK at the right place, meaning this place here. Make sure you have these correctly because there's a lot of Windows headers that's being used to compile. And if all of this is good, then your compilation should be good. So let's say, let's say I modify something here. I do save. So once you do that, and you go back to that directory, in my case, it's a different directory now. So JPads, CPTS, that's yeah. So now if I do a git status, okay. Sorry, I can't do that. It's in, okay. Because I was running, I created this Git repo from my exe batch, but now I'm with the Pratt batch, so it's telling me I don't have access to my Git repo from the. So anyhow, so I just wanted to show you that if you do this, if you make a modification, when you do a Git status, it will show you which files have been modified here, and then you then you can do a Git add and Git commit to your repo. But anyhow, we can go over that later. It's not so the bulk of the code is this is the entry point, CPTS EMUTS DLL, and from this entry point you can dive in and you can see what the code is doing. The first thing that we can look at is the read DDF. I think it's F12 if you want to go to yeah, F12. So if you go on the I think it's out. Oops. You navigate back with a control minus. So control minus is to go back, and F12 is to dive into the implementation of the method. So if you look at read DDF, basically read DDF is in FDR data management. So FDR stands for Flight Data Recorder Data Management. So that's easy to. So everything that has to do with the flight data is in this module, and then it will call other modules. The other modules it will call are these CID32 and CID32EXT. So let's go into this one. So FDR data management. So when you do a read DDF, like I was telling you, Mansi, there's a lot of code from standard IO. I don't know if if this code rings a bell for you, Pravesh, but this is all like C code from standard.
Yeah, I can recall it's all C, the
Yeah,
sprintf, fprintf. So, yeah.
This is
so
for
these are
input
like,
output functions.
Yeah, those are
sorry?
the standard library. Yeah.
Yeah.
STD.
Yeah. So you if you have the link that I provide you, yeah, the CPP reference and C++, it talks a lot about you know, you can go into the reference, and then you have the C libraries here. You have all the information about the different containers. We don't use all of these. A lot of these are C++, but the I/O and the I/O, the input streams, this is where you'll find. Oh.
Yeah, so here all programs are C. Then you mentioned that in CPP you used only for calculations.
No, everything is C. Everything is C.
Everything is C.
Everything is C.
Okay, only the interface is in C. Then C#. That is what you are saying, right?
Exactly. The interface is in C#. I'll show you the interface, how the interface is calling the C# interface, how it's calling the DLL after. It's just a basic P. It's called P invoke. It stands for platform invoke from C#. But let's go through this code now. So basically here, when we do a read DDF, basically we read the entire content of the DDF into the database. So OCI init, this is where we initialize the Oracle client interface. We open the file. No, this is an error file. So we open the error file just to write in it, just in case. This is the log. We log information, and I'll show you where we open the DDF file. Engine.
String copy. String copy. F open. So we need to see the F open.
Exactly. But you see this is where it stores the content of the DDF. So basically we put the I think the fopen the is done in here. It's not done. Basically, we pass the file name and the path to this method, and then this method will open the DDF and store it as a blob in the database. So let's do an F12 here. So we do an F12 here, and then you see the syntax here is different because I use OCI lib. I don't use OCI anymore because OCI is very. You've programmed OCI before, Pravesh?
No, actually, I used earlier. I worked on some C programs, so I worked on the compilation. So
Okay.
at that time, I heard OCI.
OCI is, I'll show you a difference between OCI and the version that I use. When you see OCI underscore, these are methods that I added. These are the functions that I added. It's very close to JDBC. If you've ever programmed in JDBC, you have like, you create your connection, you create the statement, you prepare the statement.
Yeah.
You bind all your input, output variables, and then you execute the statement. But if you look at something closer to, this is done in OCI, basically you have something like this. And then you have your queries, but when you actually do you have like these, this is very hard to read. I mean, if you're not used to programming OCI, it's very hard to read. And you know, so basically you do the same thing, but then you do an IO, you do a parse. It's if you're used to this, it's fine. But you know, when I did it, I couldn't stand reading this code, so I did it this way. So anyhow, so we were looking for the insert decomp. So if we're looking at the insert include, so you see the fopen is done here. So basically, we pass the file name to the structure here. The structure here. There's a structure for input and there's a structure output. Don't worry, Mansi. You won't need to modify this. Okay, I'm just showing you the code of what it does, but you don't need to modify this. So we open the file here and read binary, and then we store the file. Blah, blah, blah. We store the file.
Why we are going to end of the file here, fseek?
Yeah, we're going to the end of the file to get the size.
Okay.
We get to get the size of the file because we have to, you know, remember this is C, so you have to allocate the memory.
Memory for this.
Data. And then after that, you with the data, you create the lob, the large object in Oracle, and then after you read your data into the you know, into the lob, into the blob, and that's what it does here.
Okay.
And then once.
So Nathan, when we are reading the data, so it will go by, record by record, right? So record size, how we are going?
No, we're reading the full thing. This is what we do here. When we do a read here, we read the file from disk and then we store the blob directly into the table. Okay. I can't show you the Oracle tables because I have a problem connecting to JPads since I switched to.
So we are not reading records. We are reading the complete file and putting into blob.
Exactly. Okay. Because don't forget, this is binary. At this point, we haven't parsed it yet. At this point, we're storing everything as one huge binary, you know, object
into the database.
Into the database. So the database sees this as an opaque black box. It doesn't know how to read all it sees is just a bunch of binary. So maybe Mansi, you can show your screen after, but to show the database. But we have a table called JPads decomp df, and it only has like, you know, blobs and IDs. And then there's another file called decomp dfc, which has the metadata for these blobs, and then has more information. But anyhow, so basically here at this point, when we do a read here, a read DDF, we just store everything as a blob. We haven't parsed the file yet. So now let's go.
One question, Than. So we get only one file or we get multiple files?
Oh, we get multiple files. We get
Okay.
lots of files.
Okay. So that's why we have file ID and then we have below in the database. Okay.
Yeah, we have lots of files, and we can go over that later. But every file corresponds to you could have like, okay, every time an aircraft takes off for a mission, it can generate multiple DDF files per flight.
Okay. Okay.
Per flight. So you
Any
could have
number,
like,
any number, Than?
and any number. So it could be one file if it's a very
Mhm.
short flight, or it could be like 10, 20 files if it's a very long flight. So
Okay.
and there's a way for the DDFs. The way they do it in the DDFs is there's a way for them to link the DDFs together. When you read the DDF, there's something in the header information that allows you to link the DDF so that it tells you that all the DDFs belong to the same flight. And if you remember when we were talking about phase 1, phase 2, phase 3, Glenn was mentioning that at the moment right now their new black box, it generates a stream, and what that means is that when they fly their aircraft with the new black box, it generates like one file, one huge file. And what they want to do for us is that they want to break it down for us in chunks so that we can do it's more manageable that way. Because otherwise, storing this huge file into the database is going to obviously it's not manageable.
Okay. So Than, currently, for example, one flight can have one DDF file, one can have multiple DDF files. So is there any size limit? For example, if file reaches 1 GB or 1 MB, then it will create a second file. And if it size is that
So,
one, it will create third file. Do you know how?
So far, we haven't had any issues with the file size in the database. I mean, we've had issues when the Oracle database grew, and then we had to do a backup, but that was because we're not deleting old files. But in terms of file size, we don't have any issues with the file size.
Okay. No, my
I'll show
question
you
is
an
that, for
example.
example, one flight can have single file, one flight can have multiple files. Why?
Right.
How it decides it will have multiple files, it will have one file. If size is not a matter, then whole flight can have a single file, right?
No, not necessarily, because the way they did it, this is not under our control. This is the way they decided to generate it this way to make it more manageable. But it's not like if we can say, okay, we want one file, we want multiple files. The current system generates multiple files based on bytes. So that's not something that we can change. In terms of file size for multiple files, I don't think I have.
So, but every file have a header and every file will have end of file, right? So that we can understand, okay, the end of the file is there. It is not a partial file or incomplete file. We have those.
No, it's not incomplete. It's just that it has certain information, but it doesn't have the full information. So the way the files, well, maybe I can show you this right away. Let's see. Okay, these are the current file. Let's take this one for example. This is a file that I converted to JSON. So let's try to open this. Let's use. Okay, so you see this file comes from one DDF file. This one here, one DDF file. But let's say the aircraft, it could have flown a flight, and then it could have generated these two DDFs. But each DDF has its own header information. So if I look at this one that was generated in JSON, you look at this one, you see the directory, the entries, it has blocks. And each block tells you how to read the data, but you have to basically jump, because the block tells you the size of the block, and it tells you how basically it tells you the offset that you have to jump to in order to get to the information at the end of the directory. So if I look at the directory starts here, and then it's a bit long, so it goes to here, and then after the directory you have what's called a parameters record. So in the parameters record you have a bunch of records that describes each type of parameter. So you've got the time parameter, the trigger parameter, I don't know what that does. The base parameter, the military base, the engine. So all of these are different type of parameters. And once you go through the parameters, again, they have their own offset. And then once you go through, this is for histogram, by the way. And then you get to the table columns, and the table columns tells you the actual parameters that was described up there. And now you get to the data. So this is the sensor data that's recorded for each of those parameters. So here we've got the sensor data. The first column, we've got the sensor data for time.
So parameters are nothing but that fields in a table, we can say in Oracle terms.
Exactly. Exactly, because we did it this way so that we don't have to replicate. In JSON you have key value, so we did it this way so that we can save
0, okay.
So basically, you have all of this, and then you have all your data entry here. So and Mansi, if you go into the CPTS and when you generate a DDF report,
yep.
I don't know if I have that here. No, I don't have. Oh, maybe I do. BIM. So
I have a call with the web forms Vincent at 11, so I have 5 minutes.
Yeah. Okay. So let's say basically, if you can get the program to compile at first, and let me know once we can get the program to compile. I think we'll have achieved a major milestone because
that's correct.
Once you get the file and then after that we can go into this one. Basically was just to read the DDF into the database, but the heart of the program is these two, and this is where it's going to get it's pretty hard to follow in this thing, because basically you'll be jumping around from one block to another block, from one block to another block, because it's the way the program was written, and it's very hard to change that. So the way the guy who wrote the program initially, he has a file handle. The file is the file handle here, and then he's passing the file handle all over the place, and then basically this code basically just jumps to the location in the file through this file handle in order to get the block of data that it needs to get. And this will be based on the DDF file spec, the current DDF file spec. So that's why we're hoping for them to give us a CSV, so that if they give us a CSV, it's going to be much simpler to get to the data that we want without having to go to fight with the DDF file spec. But in order to do that, you still have to understand the way it works, and it's these two files here. So just to let you know, if you can go through these two files, that's and you have all the key information in order to go through these files is all up here. So you've got the block current position, the block current index, the record position, record current position, parameter current. So these are keys to basically track your data in that DDF file through the file handle.
Okay.
All right. So yeah, I think that's enough for today. I'll set up something for next week, and we'll go over it again.
Okay.
If you have
Thank you,
any
Tan. So
questions,
meanwhile, I think yesterday or before I have cloned my repository. So now Mansi will do and we'll see how to set up. As you mentioned, the important task is to set up in the
Yeah.
Visual Studio, right? And then
Right.
if we make the changes, then we'll rebuild and then we'll deploy. So yeah.
Yeah,
Yeah,
I will do the same steps which you have shown today. So I will try to see if I'm able to rebuild it.
Okay. Yeah, just make sure get the environment ready. I think
Yeah.
that's
Yeah.
it's a good first step. And then if make sure that you can compile. Compile is just do a rebuild, and it should tell you like and just keep this guy. You
Yes.
should have them bolded, and also the
Okay.
Windows SEK. If you have all of that done, then it should be good. And of course,
I asked the guy who was doing the installation yesterday to add the Windows SDK, but I'm not sure if I have the same version. It is still the updated one, but I think I have the little lower version.
Okay, no problem. You can ping me, and then we'll have a quick session, and then
Okay.
this it doesn't have to be 1022, but
Yeah.
when you install yours, what you can do is that you can I think you can specify it when you start the project. So
Yeah. Okay. While
Okay.
installation also it asked for the SDK and we did it the latest one which was available, but I will check again.
Okay, no problem. Yeah, let me know, and then just to set up the environment is a bit tricky. So I mean, not tricky, but it's a bit of a headache. I mean, especially
Yeah.
when you can't compile. But so
Yeah, I
I
think
can
first time
help you
will
guys
be
with that part.
well,
All right.
Okay.
So
Yeah.
I'll set up something else, and then we'll take it from there.
Okay.
sure.
Thank you so much,
We can
Tan.
set up the same meeting, like I'll send the invite so it will be easy for us to record.
Yeah, perfect. I'll let you